Uh,
Greg, I'm gonna mute you because that's
who is it? Anna?
Are you sharing what they can share? What was going on?
Hey, there's a lot of static on your end,
yeah.
Anna.
So I muted
Really? Okay, let me mute myself.
Oh,
It
better.
sounded like he was mauled by a dog.
need assistance, Anna. Please message us in the chat. We'll send someone. Welcome, Sam and Linnell. All right, everyone. We're gonna let people gather for the next few minutes here. We'll get going at 10:10. And yeah, so please feel free to continue to mingle. I'm gonna take a moment to do some last minute housekeeping here, but yeah, we'll get going at 10:10. Or I'm sorry, 7:10. I'm in Eastern time actually right now, so 8 minutes. All right.
Mm.
All right. Who else we got here? Oh, we've got a blank person. Welcome. We welcome all ninjas. Also welcome Ravi and Matt. All right. If it's your first SacPy, why don't you let us know, what do you do with Python? Are you learning? Have you built something recently? Are you trying to build something? Anything?
I can, since I'm new, I can just give a brief intro. So I've been using Python for the past 6 or so years. And my team uses it at our workplace, mostly for modeling as well as for data engineering. And then obviously on the side, I do consulting here and there. So mostly Python-based applications from anywhere from statistical modeling to data engineering.
Very cool. Uh, what what was your latest breakthrough?
So one of the things I've been sort of playing around with is just using Python for scraping down a lot of alternatives data sources, RSS feeds, uh, Bloomberg, CNBC, that kind of stuff. And for past, I'd say 2 years, 2.5 years, has been building topic models using topic models and some customized word-to-vec models using Python. Yeah, for a bunch of other downstream tasks.
All right, you were scraping Bloomberg. Did you see GameStop coming?
What's that? Yeah, so obviously there's a lot of chatter that started coming in, like I'd say just about a day or so before the news media started capturing it the way they did. Yeah, so there was some chatter starting to come through. And then I started looking in, there's some couple of Python packages for actually scraping or actually downloading through the actual XML. I think it's XML or JXML, some kind of format through Reddit blogs itself.
Heard that infamous subreddit Wall Street Bets is now
Yep,
being
yep.
overrun by bots.
I know.
People found their new what do you call that? It's they're sort of they're affecting markets. Is there a term for that? That sort of channel, or like, you know, if there's chatter in a particular channel, things will happen. Is there a term for that? Do you know?
Well, I don't know. I mean, if you're looking for per se a technical term, but it's just, uh, yeah, I don't know if there's any, yeah, technical term to really quote.
Well, it's wild, whatever it is. All right, we got
Yeah.
some new people in here. Welcome, Claire.
Hello.
And Linnell, I think. Did Yvette get back? Ooh, welcome, Brandy.
I'm here. Thank you.
All right. All right. Anyone else?
Hi, Claire.
Python stories. What else are we working on in Python? Sam says he's in Portland. He or she. I shouldn't assume.
I guess by way of intros, I should probably say something. I'm Jacob. I actually live in Seattle, but I'm currently working my way through a web development boot camp. So I'm just trying to learn more and more about Python, and right now I'm learning about testing and session. So yeah, and Flask.
Oh, nice.
Flask. Nice. Have you tried Fast API?
I haven't yet. No, I'm about 9 weeks into my boot camp, so I'm still.
Yeah, take it slow.
I think there's more written about Flask at this point. There's better documentation available.
Yeah,
Um,
yeah.
But Fast API is the hot new thing.
Yeah.
Yeah, I think later on in the course we get into Django, and then I'll be looking at other stuff like that.
Very cool.
What's
Cool.
Fast API?
It's like a Flask replacement,
I see.
but it's supposed to be asynchronous and sort of more performant, like as fast as the JavaScript-based web servers. So a big thing, the big secret sauce is it does async HTTP rather than synchronous that Flask does.
Uh-huh.
So, yeah.
Okay. Cool. Thanks.
I think when you talk about explaining concepts, I think one metric is cognitive efficiency, right?
Yeah.
So how easy is it to learn, and how easy is it to figure out how to integrate it into a project? And initially, just figuring out how to get something to work is more important than having it go super fast.
Yes. It's the alpha idea. At least you got to be accurate.
Right.
You can worry about low memory and fast later on.
Well, sometimes you need it to be like capable of doing real-time processing though. So if you don't get it fast enough, it's not going to be very useful.
Also true, yeah.
I believe I got my issues sorted out with my microphone here.
Way better.
Yeah, considering the alternative was no microphone.
Yeah,
So this is my first meeting with this group. What is it that you guys normally do or discuss?
Well, every month we meet first Thursday. We take speakers. We try to get them lined up as soon as possible. We, it kind of sky's the limit for what you bring to the table. If you yourself have anything you want to present on, whether you're practicing presenting or trying to show something interesting, or whatever. People come in and show off some of the work they're doing, and it turns into kind of a mingling hour. It used to be a meetup. We started, I think, 3 years ago or something like that. And we'll get into that in the intro. But with COVID, we moved to Zoom, and I think we'll probably keep some of the online stuff. Obviously, the hope is that we'll be able to meet again in person. But as we've seen from some of the intros here, not everyone's in California. I myself am in Eastern right now, so I'll probably continue on with some of the online stuff, and if I'm back in California, I'll do the in person. But it kind of turned into this like online thing, and we've published a couple of these to YouTube. And, I don't know. I met Robert, our co-host here, and he and I worked on a startup for a while and worked on a number of things, and then there's been a whole bunch of the usual suspects, and yeah, it's kind of fun. Um, I guess it's kind of what you want to bring to the table. One of the things I like to do is photo shoot. I don't know if you guys saw on the meetup, we do the kind of like Brady Bunch thing. Well, it's 10:12. We might as well get going. We got 15 people in here. That's pretty good. It's a lot more than Joe Rogan ever has on his podcast. So suck it. All right, cool. Well, let's see. What do we got? Welcome, guys and girls and theys and thems and such. It's February 4th. It's who knows what SacPy. We're at, I don't know, 40 something. I think it's my 14th since taking over in January of last year. Our glorious founder, Hail Josh Miller, who is not here with us tonight, unfortunately. He started us off back in 2017. Once upon a time, we would meet in locations in Sacramento. When I came on, we were at the Urban Hive, co-working space, pretty nice little spot. Pizza and beer. Hopefully everyone has some sort of refreshment available to themselves. I'm sorry I couldn't hand deliver this time. But Josh will join us from time to time, so hopefully we'll see him again in the future. Yeah, thanks, Josh, wherever you are. All right. Often you will find myself and many of those in this chat here in our chat channels. We've got a Slack channel. Sactech.slack.com is where you can find Slack. I also opened up a Discord channel fairly recently because why not be everywhere? I'll put the link in there, but if you guys want to take a moment, wrong way. Feel free to screenshot or do the little QR code thingy. But I also put a link to the Discord. The Slack or the SacTech one is effectively that. I'm sorry. It's possible that Discord link is expired, but the one that I put in the chat, that one works. I'll put it in the YouTube link as well if you want to follow in the future. But we're often in there talking about the next event, but also whatever. You guys know how chat channels work. We're also in the social media sphere on Twitter. Follow us at @sac_py. There's apparently a person out there named SacPy. I use SacPy. We also have a subreddit where I unwisely put the Zoom link for the first online, and we all got to experience the joy of Zoom bombing. That was amazing. I forget who was helping me moderate that day. I believe someone had lent their Zoom channel or Zoom account. They said it was some crazy rate at which people were coming in, like 50 a second or something. I think someone somewhere was scraping Reddit and was creating a kind of list of places that you could Zoom bomb if you were into that. And apparently lots of people are, or at least were at that time. Early COVID was wild. Late COVID, everyone's a little jaded, tired or something. We also have a Facebook group and a Facebook page. Yeah, if anyone wants to help populate some of those channels with things, I think it'd go a long way towards increasing the membership. But yeah. All right, here we are, and this is all our 2020 glory. After this slide, I'd like to take a moment and maybe everyone could grab something around them. I didn't really put a call to arms. I'll put the Slack. Oh wait, let's go back real quick. It's SacTech. It's real simple. A moment. Thanks, Eric. That's a good idea. that should work. Although Tanim, I think you mentioned that you may have had some issues with that in the past, so I don't know. But if everyone's got a moment, look around, find something funny, put it on your head. If you got a mask, throw it on. I'm gonna put some headphones on. We did funny hats last time. I'm gonna put it in the Brady Bunch mode, and then we'll. How do I do the? That's full screen. That's great. Come on, give me that big grid though. Oh, there we go. Ooh, I think that's most everyone. All right, we'll give everyone I don't know, 10 seconds or so. Let me change my background now. Awesome. Thank you all for playing along. That'll make for another fun round of Brady Bunch SacPy mode. All right. Ooh, let me close my little Brady Bunch thing. That is dominating my screen. Awesome. All right. So first up, we've got Dan Koellen back again. I believe he may have shown us a thing or two about this in years prior, but nothing that had made it to YouTube. So this will be Dan's YouTube debut of his
All right.
ham radio-ness. I believe he's going to be working with a messaging channel called Telegram. I'm sure many of you are familiar with, and a little device a lot of you know about called a Raspberry Pi. And that thing on the right is what I found to be maybe the symbol for ham radio. Is that right, Dan?
That's yeah. That's used for as a radio. Yeah.
Cool. All right. Well, I
Great.
will kick us over to Dan. Dan is our first speaker of two tonight. Take it away, Dan. Oh wait, let me make it so
Yeah.
that you
Give me a
can
share screen there, if you can.
there we go. And all right, Dan, take it away.
Okay, there we go. Let me get my share screens up. All right, everybody. So do you see the PowerPoint slide?
Yeah, and we see your IDE in the background too.
Okay,
Etc.
perfect. Yeah, everybody. I'm Dan Koellen. So I'm a ham radio operator and also a novice Python person. I'm just a hobbyist, so I don't do this for a living. So just bear with me as I go through the Python. But so I learned Python just for doing some hobby stuff. And one of the hobbies I have is ham radio. And the ham radio nowadays is a lot different than it was back in the days when you had the big radios and a bunch of dials and tubes and stuff like that. So I've got a right here that's all software defined radio. All the processing is done by software, and it has a web server. So the control is through the web. You can see that there's no dial on it. So this shows a screenshot of what it looks like when I'm operating the radio, and I can just do it on my computer. So what I've done is I've put the radio outside in an enclosure close to where the antennas are, and that way I can operate the radio from inside my house or wherever I want to. And I can control the radio completely over the web using my computer or other hardware. So that's really good, except there's one thing you can't do, and that's turn the radio on and off. And that'd be a good thing to do because out in the outside in the summer, it gets really, really hot, and sometimes it's just too hot for the radio to be running. So I decided, okay, I got to build something that I can turn the radio on and off, and I can also monitor the status of the radio. So whether it's on or off, and also the temperature and humidity in the enclosures, which is pretty important. And I need to be able to access that anywhere. Since I can run the radio anywhere in the world, I need to be able to access the control monitoring that I want to do for the radio. And also I want to know if for some reason I lose power or the radio turns off or turns on unexpectedly, I need to know that. And I also need to know if somebody's trying to, I guess you could call it radio boom me and trying to come in and hack on the radio. So I looked around for different ways of doing this. And this is something I did a couple of years ago and actually presented here an early version of what I was doing. And I decided to use Telegram. And Telegram is, reason I used it is because there's an app and a platform for almost every operating system out there. So whether you're using your phone or a desktop or a tablet, there's a way to use Telegram. So the last couple of meetings, we talked about bots for Discord and bots for Slack. So I thought, well, let's do the bot for Telegram and go through it again. So I built it, and it looks like this on Slack. And if I send in, I can get the temperature and humidity on the enclosures I have. My radio is called Flex. So this is the enclosure that the radio is in. And this enclosure is a separate enclosure for my control system for my antennas. And then here, just by sending flex status to my bot, I can see when the radio was turned on and how long it's been turned on and who turned it on, whether the bot turned it on or not. And can everybody see the Telegram here? Did I share that? Woody, can you see the Telegram?
Yeah, I see your Telegram and
okay.
The other two.
Okay, perfect. So let me just show you how it works. If I put in flex status, it will come up and it shows the time that I access the bot, how long the bot's been, or the radio's been on, and who turned the radio on. And then if I just put in ambient status, comes in, tells me what the temperature and humidity is in the box for both enclosures. And I also use Flask and SQL database, so I can access the server I have that shows the temperature in the enclosures, humidity over a period of time. So all this is running on Raspberry Pi, and works pretty well. So I've been using it for a couple of years. So let's so the way that I did it, well, the way you create a bot in Telegram is use bot father. So if you have the Telegram app, you just search for bot father and you ask it for a new bot, and it will say, okay, let's create a new bot. And this is where I create the bot for my controller. And you just give it a name and also a username. And then it gives you a token. And just below this is the access token. And the access token is this long, boy, it must be like 16 or 20 characters of upper and lowercase letters as well as numbers. And that's how you access the bot is through your app. You can use the token in order to access the bot. So I built this back in 2019. I used a library called Telepot. And when I was preparing the material here, I saw that Telepot was no longer supported. So I found another library that actually works, I think, better, and it's Python Telegram bot. And I really recommend that if you want to build a bot for yourself on Telegram, use that for the new builds. But we'll take a look at both. And so we'll start out with Telegram or Telepot. Telepot's up on GitHub. You can find it, and it's pretty easy to use. Basically, you import Telepot, and then you also have to do a import of message loop. A message loop keeps the bot or your Python script to keep on updating from the bot. So every time that your bot receives a message or a command, it will send it to your script. If you only run Telepot, then the script runs once, and then you never see any other messages coming up. So when you set up the bot, you use telepot.bot and just put your token in there. And I call my bot Hambot. And then you set up this message loop, and action is the function that runs whenever you get a message. And that's how you do it. Now, the scripts I'm going to show you tonight, I actually wrote a article in a ham radio technical journal about using Telegram to control your rigs. So I just stole those scripts. So there's going to be some ham radio lingo in there. I'll just warn you ahead of time, but we should be able to get through that okay. In Telegram, you can send messages, but there's also commands. And if you want to send a command, it's actually a / followed by a word, and those are called commands. So there's a couple different things that you can send to Telegram. So let's take a look at some code. Let's see, let's do, this is Telepot. Can everybody see my Notepad++, the code? Okay, perfect. So basically, I've got some functions defined here that happens when a message comes in. And this is where I set up the bot and then message loop. And whenever a message comes in, it goes into this function. And the thing about Telepot is that you have to put a lot of the intelligence in the function that happens when the message comes in. So if you want to restrict users, you have to do that in the function, as well as indicating if there are certain words in a message, how you want that to react. So for instance, here I have a list called users, and only if the ID of the message sender is within the users list can anything happen. Otherwise, you're bopped out of there. And for instance, if a message comes in with LED and on, then the bot will send a message that the ham bot is turning on LED, and I have this on Raspberry Pi, and the LED will turn on. So it's pretty easy to use, but there's definitely some restrictions on it that could actually be improved. So looking at Python Telegram bot, there's some differences there. You can find that up on GitHub as well. To use it, again, you just import telegram.extension, ext, and you have to import some packages here. You have to import updater and handlers and filters. Now the handlers are what actually handles either a message or command or whatever might be sent in from Telegram into the bot. And those are pretty handy, and it's actually better than Telepot. So I'm glad that I found this library. So to set up the bot, you set up an updater, and the updater, you put in the token so the updater knows where to go to find the bot. Then whenever a message or a command or whatever else comes in from the bot, the dispatcher will send it out to appropriate handler, and the handler is what figures out what to do with the message or the command. And then the updater start polling starts the bot and keeps the polling going on. So whenever a message comes in from the bot, it's sent into the dispatcher. So this shows some of the handlers that are used. You have to set up a handler for each of the message type or a command that you want to send that is going to be coming in. There is quite a few different handlers. You can see here, this is a list of all the handlers. I've only really worked with the message handler and the command handler right here, but you can see that there's quite a few different handlers. So this in itself is much more useful than the Telepot, and it's nice to use. So for instance, this is a handler for commands. So this is set up so that if the command /time is sent in, this command handler will detect it and then send it to the function that's defined by time. And then you have to tell the dispatcher, hey, here's the time handler. Anything that comes in with time, send it to me. This is a handler for messages. And in this one, I've got filters. And the filters are really nice also because, for instance, here, I'm filtering where only text will be handled by this message handler. No commands will be handled by that message handler. And then the function that does the execution is called action. So we'll be looking at the filters a little bit more, but that's another nice thing about Python Telegram bot over Telepot. And for instance, here I've set up a message handler for an unauthorized user. So I'm using a filter here for whoever's not on the user's list goes into this message handler, and then it tells you, hey, you're not supposed to be in here. So we can look at some code for that. And so this one I set up. This is actually running right now. If you want to play with it, you can. It's actually running on my Raspberry Pi right now. And basically, this is where I set up the bot and the dispatcher and the polling. And then these are all the handlers. So this is like the example I have. So there's two commands that can be sent to this particular bot as it's running right now, /time or /dog. And then also there's also some other messages that get, if you send CQ or the date. Now, this is some ham lingo up here. CQ is basically like calling all stations. So this is for whenever you want to make contact. So if you want to make contact with the bot, you send a CQ and you'll get a message back from me. And same thing, if you send date to the bot, you'll get the date back. If you send a message that's not CQ or not date, then you'll get a nice message that says TU, which means thank you for your message. 73 and 73 just means best regards, bye-bye. So this is running on SacPy Telegram right now. And looks like somebody sent CQ. You actually have to send either capital C, capital Q, or small c, small q. There we go. Cool. And if go ahead and send /dog. Anybody can access it right now.
All right, I'm sending /dog.
Yeah. Yeah, we got
got
3 dogs.
All right.
Got 3 dogs right now. So this screen right here is I just SSH into my Raspberry Pi. And So it's kind of fun to do.
Yeah, you said the dogs come in from some website that has. Oh wow, that doesn't really work with the virtual background moment.
Yeah. That's why my virtual background off too.
There
You
we
can't
go.
see the screen. Yeah. And I could actually do it too. You can see some of the dogs that I've had. Good. Hey, the Pi isn't crashing yet. I didn't know how much the Pi would be able to handle. Yeah, so the website is random.dog/woof.
Nice.
And I didn't come up with this. I found this on the internet somewhere, and I just changed it so it would work within Telegram. So this script right here does a little bit more, and this isn't running yet on the Raspberry Pi, but I'll run it next. And basically, I have a LED that's hooked up to the Raspberry Pi, and Woody's the only one other than me that has authorization to run this bot. So I'll set it up here in a little bit. But basically, if you message LED on or LED off, it turns on or off LED. And if you ask for LED status, it will respond back with the message whether the LED is on or LED is off. Now, this is pretty simple, but this is what I use to check if the radio is on, to turn the radio on and off. And then I guess I can show it here.
Yeah, if you want to hold it up, I can send a message.
Yeah, I haven't. Let me. I still got the other script running on the thing. So in my ham radio setup, this is where I get data. So I've got an SQLite database that's running with humidity and temperature that's measured every 15 minutes. So that's what I actually do in my application here. So yeah, so what's real nice here, like this handler right here, just being able to use the filters really makes it a lot easier to use. So you don't have to put all the filtering in your function. You can just do it right in the handler. So it's pretty nice. I rather have used this rather than Telepot, but Telepot was the only thing that was around a couple of years ago. So what I'll do here is, anybody else want to still send some messages to the bot, or can I change the script? Okay, I'll go ahead and kill this. $736. Okay. Okay, so Woody, if you want to send LED status, okay, LED on. So see the LED came on. If you want to
Turn it off.
Okay. There we go. And then I actually get
like a DJ.
And I'll show you, I get messages when it's turned on and off to my account. So cool.
Yeah, it's too much power, man.
So yeah, so this I think this bot works. It's fun to do. You can do a lot of different things. I'm just doing some simple things, but it really helps me just keep an eye on things. I don't have to, every now and then you have to boot things on and off. Or what I found also is during the winter that I just have to run the radio more because the humidity builds up in the enclosure a lot. So good. So that's turn it on. Want to turn it off, and then I'll kill it.
And off. There we
There
go.
we go. And then if anybody else wants to actually send a message to the bot right now, you should get a message that you're not authorized and go away. So if anybody
Very
else wants
cool.
to send a message. So good. Yeah, that's pretty much what I have, I think. Yep. Somebody made an attempt here. Oh yeah, here's I should have put that screen up so that everybody can see how to use the thing. So any questions or anything you want to ask?
Have you stress tested the Raspberry Pi? Like how many inputs can it handle?
I don't know. This is the most inputs I've had before because it's pretty much just myself using it before and some of my friends just to test it out. But
All right. How long have you been into ham radios?
really since I was a kid. And so, you know, the fun thing about ham radio is you can build your own radios and antennas and things like that. And what I like to do with ham radios, I've got a really small radio and portable antenna, and I like to hike. And I hike up to the top of mountains and then set up my radio and antenna there and operate from the top of the mountain. So it's fun to be up at 9,000 or 10,000 feet and just communicate. So with just a few watts, I can communicate with people from all over the US, Europe, New Zealand. It's pretty cool. It's fun. So
Any other ham radio operators in the group here?
I actually had a question. Is this microphone working? I actually swapped over to another one.
Yeah, we can
it
hear
is. Yep.
Okay, great. So I was kind of, I might have just missed it. So how exactly does the whole setup work? Like you have your ham radio connected to what, the Raspberry Pi or the?
Yeah, so I have a Raspberry Pi that's out in the enclosures with the radio. And so I've got Ethernet out there because the radio runs off Ethernet. So the Raspberry Pi is on Ethernet. And then
you're not running like a repeater or anything, it's just its own individual little unit? Or I don't really know how ham radio works all that well.
Yeah, so the radio I have actually has a server in the radio itself. So that's how I communicate with the radio, is through the server that sets up within the radio over the Ethernet connection. And then the Raspberry Pi that I have out there, I just use to monitor the temperature and humidity in both of the outdoor enclosures, and also monitor whether there's power and turn the radio on and off.
Right, and then how does Telegram exactly factor in there? Is that running on software on the Raspberry Pi, or is that?
Yeah, so the scripts so this script right here, this is the script that I use within the Raspberry Pi.
Okay, makes sense. I think I just wasn't paying attention for the really early part of the talk there. So
yeah. So there's some hardware that I built because you need to be really careful. The Raspberry Pi is not that robust. So I have like a number of opto isolators and things like that just to protect it and make sure it's got the right interface to the radio as well as to the temperature sensors. So that's how it's done. And
then you said you have it out in an enclosure, so I'm assuming it's kind of like not. How exactly is the Raspberry Pi getting internet connectivity out where it is?
Yeah, I have Ethernet dropped out there.
Oh, so, okay. Yeah, I kind of just like had this picture in my mind of like something like kind of sitting out in the woods or something, like kind of too far away from.
No, it's actually in an adjacent lot, so I have Ethernet out there. But I need so I need Ethernet for the radio. So since it's already out there, I've got Ethernet for the Raspberry Pi also. And I can let's, I can go in here. So this is my page here. This shows some of my operation up on mountains here. That's up on Granite Chief
Oh wow.
at 9,000 feet. And this is Mount Lincoln. And this is Donner Lake right here, overlooking that while I'm operating. And that's a little rig. So this looks kind of ugly, but these are the enclosures I have for the. So they're on the middle of, in the middle of the sun and rain and everything. So that's why I've got to monitor what's going on in there. So.
And how long have
Very
you
cool.
been doing Python or programming in general for?
Oh, probably about 3 years, something like that. So I really learned it for the Raspberry Pi and some, which I present some. I do monitoring of my irrigation in my garden. So I built a irrigation monitor that looks at how much water is delivered, the duration, and make sure that the water flow is what it should be in case there's leaks. So that's why I really learned Python 4 so I could build that. And then I came up with this application. So it's a lot of my code that I learned, whether it's Python or C or assembly, is driven by what I need to build for some of my hobbies.
How did you? I actually have a friend who's going to start almost that exact same project, except for he involved like a 3D printer for like a flower pot rather than a whole garden.
Yeah.
How did you calibrate like your water like usage and when it's going to be dry and all of that?
Yeah. So there's a couple ways of doing it. One way is you just stick your finger in the pot and see. But there are soil moisture sensors that you can use. And the soil moisture sensor will have a change in resistance according to how much moisture is in the soil. And then you can use that to determine whether the plant needs to be watered or not. If you know, there's a lot of people have done that. So just Google it and it should come up, you know, on Instructables and stuff. My system's a little more complicated. I've got about 1.5 acres with several stations. And so I monitor really closely how much water is being used, because I have another problem. I have, there's varmints out there that actually eat through the tubing or will actually eat the valves. So my system can determine whether there's holes in the tubes or if the valves aren't working. So I think I gave that a couple of years ago. I can talk about that again sometime, but that was kind of fun to do, and it's just it's a pretty big program to run, and I can access that. I have a little web server that's I can tell how much water is out there and how long it's been. It's not operating right now because I don't do any watering, of course, during the winter, but during the summer it works pretty well.
Well, maybe we can get you lined up for yet another awesome hardware presentation.
Yeah, sure. Or we can.
No, I know.
After,
I know.
After,
Tanim has.
Yeah.
Sorry, I know Tanim's had a long day.
Yeah, we'll let him go. So, but any other questions? But yeah, maybe after COVID we can actually have a session in the garden.
Absolutely, that'd be awesome. Hey, Internet of Things is cool.
Yeah.
That was an excellent presentation, if I may say something. So thanks so much. That was lovely. And I just had one question. You mentioned just now that you found the Raspberry Pi is not very robust, and I agree with you on that. So have you been able to see something? Have you been able to find some alternatives, or did you find, like, does the device crash sometimes and then you have to reboot things up? What were the challenges?
Yeah, there's a few. Can I take a couple minutes, Woody, or should I Go or
Yeah, I think.
so.
Hey,
to you.
Tanim, are you still awake?
I'm still awake. Yeah.
Okay, so
Okay,
real
cool.
quickly, there's a few things. Like for the garden monitor, that's outside, so when it's really hot, the Raspberry Pi doesn't seem to work real well. And I do a reboot once a week because I do find that the Raspberry Pi sometimes just stops. You just have to reboot it. So I just reboot once a week. And then for the ham radio application, the outputs, the inputs and outputs are not very robust. So I use opto isolators just to make sure that there isn't any kind of noise or anything that will harm the inputs and outputs. But yeah, I like to find something that works better at higher temperatures than the Raspberry Pi.
And I think that might be probably sometimes the micro SD card kind of gives a little problem, but maybe the Pi Zero, which they're now introduced, that might be a better alternative. Try that out probably.
Yeah, I actually use the Pi Zero on the ham radio controller that I presented tonight, but I just switched over to a Raspberry 3. It just works better. The Pi Zero is just too slow.
Have you considered, instead of trying to replace the hardware of the Raspberry Pi, trying to look into some sort of like homebrew cooling solution? It looks like you got a pretty big enclosure out there.
Yeah, homebrew what?
Like cooling solution. Some sort of fans or ventilation.
Yeah.
Yeah.
So
if you're feeling ambitious.
Yeah, so the large enclosure has vents, and I probably will put some fans in and just use the Raspberry Pi when he detects the temperature is above a certain temperature, then I'll kick the fans on.
You were saying every week or so you had to reboot it. Is that meaning the operating system itself was seizing up, or you were running this the script continuously and you found that the script needed to be restarted?
Yeah, the script was running was running continuously, but I would just reboot the whole Raspberry Pi. So like every Friday night at 12:05 a.m. or whatever, I would just reboot the Raspberry Pi.
Did you do that manually, or do you have like a cron job set up on the Raspberry Pi?
Yeah, just a cron job. Yep. Now, I can also SSH in. Even when it locks up, I can still SSH in most of the time and reboot it manually if I really need to. But I just run a cron job.
Cool. Any other questions?
Yeah, go to my website or there. Did you put the GitHub up, Woody?
The GitHub is in the meetup, but feel free to
Okay.
throw stuff in the chat. And
Okay.
Also
Perfect.
Yeah. Awesome. Well, thanks so much, Dan. Always really cool hardware demonstrations. I love it. Can't wait
welcome.
for your agricultural demo. It'll be a good one.
Sorry to go over, Tanim.
That's okay.
All right. Well, next up we got Tanima Islam with a whole bunch of really cool stuff for us tonight. He showed us a little last month what he was working on. He couldn't tell us what he does for the government, but he shows us what he does in his free time, and it's pretty cool. So I can only imagine what he does when someone's paying him. But he's doing some things with NumPy, and that one on the right is FFmpeg.
Yep.
Right? And then just doing some cool stuff with visualizing what all's going on with COVID here in the States. I'm sure, well, we may not have all people in the States here, but yeah. And then some other things he does to, automate some boring stuff.
Automate the boring, yes. All right,
That's
so
right.
So you
All
want
right,
to
so
hand?
I will pass the sharing to Tanny.
All right, let's see if this will work. Okay. All right, let me just get everything up and running. So gotta view, meeting, start share. Oh, there we go. 1, 2, 3. There's 3 things. And I'm going to start with the presentation, and then I'm going to go just demonstrate stuff. So the description that Woody gave in the meetup was a bit of a bait and switch. He is talking about something I do hobby around with, which is the COVID-19 tracker. But I thought I'd start simple, which is these tools that I've developed in Python. They're all conceptually simple, and I use them all the time. So by conceptually simple, I mean I make lots of presentations. I develop a lot of figures, and if they've got a lot of white space in them, I want to, auto crop them. And instead of paying for a tool, I just wrote something up in Python that's a nice command line thing. It takes in a file and creates something that just removes all the white space. Another one, you have like a bunch of images, basically a movie with a frame separated out, basically a set of images frame by frame. Create a movie from that. And the third thing I'll talk about is if you want to host something online, like on GitHub or Read the Docs, they won't let you put in your animated movie file like an MP4 or an MKV, but they will allow you to put in an animated GIF. And so I just made a tool that is steered by Python that does that for you. And with that, I guess I can just begin. So I call this Python for quick, useful multimedia manipulation. I call it anecdotes from a Python programmer. And I'm not a formal software engineer or developer because I just program to, scratch an itch or solve the problems I see in my day-to-day work a day or hobby life. So that's how I keep programming fun for me. So, yep, I guess went through that. That's if because I don't have a screenshot for my user ID on Zoom, and I don't have video. This is an old picture of me from 2012. Wow, it's about over 8 years old now. But yep, that's me. So I make and manipulate lots of images and videos in my day-to-day work. And the demonstrations I'm showing here, I'll describe really the first three things: the auto cropping the images. You create a video from a collection of images, basically frames as PNGs or JPEGs, and animated GIFs. And if we have time, I'll demonstrate a tool where you get a song clip from YouTube, you get the metadata from someplace else, and lo and behold, you have a music file with all the, artist and title and everything correctly arranged in the file sitting on your disk. And all this code, it's actually all in this presentation, and there's a PDF of it, which is in its own GitHub repo that where I have all the links, that I describe here. And the stuff that I'm demonstrating today comes from 4 places. These 3 at the bottom are GitHub repos that I hobby around in. And the one on top is a GIST. It's basically an executable Python code that I've deployed just standalone into GitHub that demonstrates that is a command line tool to create, a movie from a bunch of images. So the first demo, you've got an image, it's got a lot of white space, you want to auto crop it. And conceptually, it's pretty simple. You use Python functionality. In this case, it's the imread, which is I think part of NumPy, to load in that image and create it into a NumPy array. So the coordinates are its horizontal and vertical pixel coordinates, and the values are its I think RGB alpha values. So like I think it's like 0 to 255 red, green, and blue, and 0 to 255 in the alpha. And that's what I describe here. And the operation of auto cropping it is just looking at the first and last pixel coordinates horizontally and vertically, the ones that are like not white by default. That's your bounding box. And then use, I guess, the Python image library, or actually, I think it's a Python image library to just now remove everything outside the bounding box and save to a file. And that's image cropping. Now in the PDF, there's also similar functionality that doesn't operate on normal image files like JPEGs, PNGs, TIFFs, and some others. There's also similar functionality that I have that does the same for PDFs and maybe for PostScript files too. But what it does there, and I don't actually understand the code very well, is it uses Ghost script to figure out, calculate, or extract the bounding box of this PDF, and then does PDF operations using the PyPDF2 library to, okay, taking this bounding box, here's a new PDF or the same PDF file that has the white space cropped out. And that one is less of a stuff that I really understand very well, and mostly code that I lifted, but with attribution from the internet. And all I've done is just wrapped it up in sort of a function whose arguments, inputs and outputs, make match what I did with PNG and JPEG files. And with that, I'm going to go into a demonstration here. So this one, the auto cropping images. Let me just, can everybody see this? You should see this main shell. It's called auto cropping images here.
So they'll never find
Yeah,
out
we
since
can
you
see the shell, and we got your presentation in the background.
That's okay. I mean, if my pet parrot were here, he would probably want to talk too. So to demonstrate what I'm doing, it's kind of harder to see with the PNG. So I'm just going to show what the PDF. So I'm going to just, to make things honest, I'll just delete it here, the cropped image. And let me see if I can show you guys the image file. Let's see, your screen sharing, new share. Yeah, okay, that seems to work. Let me open, yeah. Okay, so I'm going to open up this thing called uncropped PDF. Yep. So this is actually, an image I demonstrated, I prepared for some high school presentation I gave at my alma mater about scientific Python programming. So as you can see here, right, you've got a matplot libplot with a lot of white space on the side. So now what I'm going to do is I'm going to run this auto crop image. Oops, let me see. Auto crop image. Let me just, I never remember, the syntax. So -H is my, best friend in terms of, Python command line interfaces. So you give it the name of the file. Was it uncropped? And let me see. Output. So you see it generated a new file here. And let's see if we have it. And can you guys see this image? So there's something that's supposed to be called cropped. Do you see that over there? Or I know it's kind of hard to see. Oh, let me share. Yeah.
I only see the uncropped.
Yeah. Do you see it now? It should be this new image right now called cumulative plot emission.crop. And maybe it's easier to see. Yep. All the white space is just erased from there. And I use stuff like this, as I say, all the time. In fact, the demonstration images that if you've gone to any of the links in my Meetup, you might have seen a bunch of movie files, I guess, in one of the Jupyter notebook or both of the Jupyter notebooks. So one of the important steps in creating those images is I have a snapshot which is, matplotlib PNG plot. And what it does is it does an autocrop operation on each of those frames. And that's how come there's no extra white space around them. And it's in an API programmatic sense, the same thing that I did with this command line interface, just automated and parallelized. Okay, so with that, let me go to, feel free to chime in with any questions as they come up. So
Yeah,
the
I
next,
actually had one.
yeah.
If you have a non-square white border, how does it resolve that? Does it end up cutting in funny?
Well,
Part of me
by
wanted to give you kind of a gotcha image to see if we could test it.
good point. Let's say you've some kind of spade, right? That kind of shape, and what it does, it's just an argmin and argmax. So it finds the leftmost non-white pixel, the rightmost non-white pixel, and the bottommost and topmost, and then just squeezes it to that point. So yeah, it's just basically some kind of triangle, bounding box, rectangle bounding box operation that it does.
Gotcha. Yeah,
Hmm.
so it helps if it has a box and then a whole bunch of white space, but if it had some sort of triangular thing jutting to one side, it would just go to the very bottom and then cut up or down.
That's right. Yes. Yes. It's still
Okay.
you'll still end up with a rectangle. So, its functionality is in general, it's not a sort of a wrapping operation, right? Trying to find maybe the convex hull around it. It's more, yeah, it's just a rectangle. And because I create a lot of, matplotlib images or process them, that's I guess that's my use case. So, okay, with that, let's see. Second one is creating movies, right? I use this, fairly often, especially now with the COVID-19 tracking hobby that I have, which is, creating movies showing the progression of COVID-19 cases and deaths, both in the continental US and in regions inside it, like metropolitan areas like New York City, the Bay Area, and individual states. So yeah, you've got basically a frame a day from beginning to the like today or yesterday, and you create a movie that goes from beginning to end. And so yes, this is the movies from a movie from a bunch of JPEGs or PNG files. And I'll show two examples here. The first example was a scientific demonstration that I also gave to a bunch of high school students, which is the concept of a Monte Carlo Markov chain. At a high level, it's just saying, if you have a complicated distribution function, say in 2 dimensions, MCMC Monte Carlo Markov chain is a efficient and robust way to sample that distribution with a bunch of points that that hop around. And the way this looks conceptually is from smallest number to largest number of points, it just sort of fills in the image. And the progression that I showed here is a bunch of images with increasing number of points from like nothing there to, okay, here's a pointillist demonstration or pointillist visualization of myself, at frame 255. That's just I guess, here's just the presentation going from frame to frame to frame to frame. And this density, this probability distribution function or density function is just a grayscaled, picture. So dark is, density of 1 are dark colors, and density of 0 are light or no colors at all. And here's the syntax that goes through it. And let's see. The other one I think that's a little more interesting is this COVID-19 tracker, which this is actually July 4th, because I gave a version of this presentation to a Richmond Python users group, Richmond, Virginia Python users group on July 7th. So this animation of COVID-19 cases in the continental US runs from the first case, I think was just a little over a year ago, right now, to July 4th. As you can see, back in the good old days when we only had a little over 2.8 million cases cumulatively. But yes, the Southwest looks bad, and the Northeast and parts of Miami, Florida look pretty bad. Okay, so with that, let me just go to demonstration mode again. And let's see, let's go to demo number 2. So if you've seen me hop around, I'm using a tool called Tmux, which allows me to basically have a bunch of windows in a single like terminal shell that I can hop around. So I don't have to have a bunch of separate terminal shells floating around. It's really a lifesaver when you have something like 8 different projects with 10 different windows per project. If you've got all that stuff floating around, your machine tends to get slow. So this is a way to keep it organized and the machine relatively fast. So, okay, here we go. Can everybody hear me? Yeah, I didn't know if...
Come through loud and clear.
Okay, yeah. All right. So here's what I'm going to do. I'm just going to go through the thing that I was describing here. And let me make things honest. You see these 2 MP4 files, right? CONUS ** MP4, MCMC images MP4. I figure, let me delete them. And there's sort of the syntax here that I'm going to do. So as you can see, the name of the gist, which is that, Python executable that I run, the prefix is, img, and I'll demonstrate exactly what that means. This is just the prefix of all those files. You see, basically frame by frame, the suffix is a number.png of that frame. Prefix is, in this case, img, the thing that they all share. So, let's see if this goes. Let me go back again. Oh, movie demos. Okay, yep, let me go through this. And FPS says, how many frames per second do I want to do? And I got to tell you guys, I'm really glad that FFmpeg exists, because it was probably a few $100 billion of capital expenditure in terms of programmer hours and resources to make that thing as polished as it is. I'm kissing the ground on my knees, grateful that it works as well as it does for so many situations. I haven't even begun to scratch the surface of its functionality, and it just works without issues for anything that I throw at it. So, okay, I've gotten this, and what I'm going to do is just show you what it creates, and I'm going to do another screen share. Ooh, share that, and just you should see this thing called MCMC images. It just takes those images from the directory, frame by frame, and constructs a movie out of them. Back when I was a bit thinner and 8 years younger, and I guess I was wearing a suit and tie for some reason. Voila. Okay. And let me do the same for the COVID-19 cases in the continental US. Do-do-do. It's. I should mention that, in this GitHub repo that has this presentation, there's also those demonstration directories with the instructions in both readme.rst and readme.html, just to get yourself oriented on the demonstrations that I'm showing here. Do-do-do. Oops, FPX equals 5. And here we go. Let's open that up with QuickTime Viewer. And let's see if it'll share the screen. Okay. Let's see the QuickTime. You should see something with nothing or just a little thing up in the middle left corner, continental US, one case in one of the counties in the Seattle metro area. And just to see it fill up. So 5 frames per second. I think 165 frames. So what is that? 35 seconds from beginning to 33 seconds from beginning to end.
And the intensity of the colors is based on that end value determined on July 4th, right?
Right? Yeah, actually, good point. I set the maximum to be sort of the maximum number of cases. I think it was not the maximum. I think the maximum number of deaths. Yes, I had a psychological purpose to the coloration that I showed here. Instead of being colored to the maximum number of cases in the region of interest, in this case, the continental U.S., it was the maximum number of deaths, which is 1.5 to 2 orders of magnitude smaller than the maximum number of cases. So something like at the time, New York City itself, which was counted as one county unit instead of the 5 boroughs, had something like 100,000, something like 30,000 deaths total. So 30,000 is where the number of cases pegs out at, and you can sort of see that in the color bar. And so because of that, a lot of counties in the U.S., especially in the continental U.S., had more than 30,000 total cases cumulatively of COVID-19, even by June, and that's what you're seeing there. Swaths of red in the Northeast, in Florida, and California and Arizona look really, really bad. California, Nevada, and Arizona look really, really bad. Also, nobody really looks good, but sort of those are the things, at least to me, that really pop out.
So this is all aggregate, right? It's not, there's no like per capita.
Yeah, I do have the data all there where one can actually get that information. But yes, this is the aggregate cumulative latest.
Quick question. So as you're kind of going through frame by frame, and for each frame, as you're showing the progress, in that given frame, the coloring is basically the totals until that point of time. It's not like we've looked ahead and we know what the max is going to be, like, let's say 6 months from that frame onwards.
Yeah, it's
right?
not a predictive, at least the way that this is designed. It's a best estimate. Yeah, it's a cumulative. It's the maximum cumulatively recorded in that county.
Got it. Until that point, when the frame
Until
is
that point.
showed up. Okay, cool. Thanks.
Yes, exactly. Mm-hmm. All right. The third thing I'll show you is, let me go back to the presentation again, is, okay. Well, I should end on this point is, the thing I can talk about later on, not today, is my COVID-19 tracker, which I update regularly. It turns out like on average every 3 days. And the stuff, once it's updated, lives in a public website. It's actually one of my GitHub pages. And the one for the continental US has that particular address in it. And that's, of course, also in the presentation that I have. Now, the third thing is, how many of you people use stuff like read the docs or, do any sort of images that you put on your GitHub, repositories? Uh, I know I do it a lot. Do any of you do anything like that?
Oh yeah, absolutely.
I
Pretty
bet.
much every time
Yeah.
you're gonna make a GitHub repo, the README is gonna probably have some sort of screenshots or images in it.
Right. But have you noticed, any of you, for instance, tried to put in some kind of animation in there? I found out fairly quickly, since I never read any documentation, I tend to bulldoze ahead, is, okay, I've spent some time creating an MP4 file, which, displays fine on my browser, but then I put it into either read the docs or I put it into, the GitHub README part, right? The thing that's supposed to be displayed in the browser, and it says GitHub or read the doc says, sorry, no, we're not going to do anything that you want us to. It's just going to be either a screenshot or some kind of broken link, right? So it's kind of an annoyance, at least to me. And so, they have restrictions on MP4s or any kind of movie files, but they don't have on animated GIFs, at least not as severely as they do on MP4s. So I looked around online and found, basically an FFmpeg script to create pretty high quality animated GIFs from movie files. It actually works on anything that FFmpeg can read. AVIs, MPEGs, MP4s, MKVs, and those are sort of the big ones. And then there's like stuff down in the 1% or less level in terms of video formats. But it seems like, FFmpeg can do that. And this is one of those, I don't know how it works really at even a medium level, but it works very well. And what I did is basically wrap that functionality that existed basically a bash script, so to speak, into, Python subprocess modulating. So wrapped it in a way that now it works as a Python method. Input is an MP4 or any kind of movie file. I think it only works for MP4s. Output is an animated GIF, that's sitting on disk somewhere. Now there's two functionalities. I'm just going to talk about one of them, which is, the MP4 sitting on your disk, turning that into a GIF, an animated GIF. And if you're looking at this part here, I'm not really going to talk about this thing called first pass and second pass, because honestly speaking, I'm not enough of a multimedia or audiovisual expert or even FFmpeg user to understand why it's done this way. It's just something that a prescription that I stumbled upon, and that seems to work very well. And yep, I'll just get to it at this point. It's actually one of the executables, Python CLI executables in NPR stuff. And so here's some of the movie and YouTube are the ones that do the thing. The YouTube one takes a YouTube clip, downloads it with YouTube DL, and creates the GIF. But I'm just going to show the creation of the MP4 file. And let's see. One problem, though, I don't know if you guys have seen this before, but the animated GIF is generally a lot larger than the input file that you start out with. In this case, the input file was about 1.8 megabytes in size, but the output animated GIF is about 32 megabytes in size. And some more inside baseball before I go into the demo. GitHub, and I found this out just by stumbling upon it, GitHub says we can only, if you have an external animated GIF that is basically an HTTP reference to something else, the limit that GitHub allows is, I think, a hard 5 megabytes. So even if you're a little over 5 megabytes, what your readme.rst or readme.md will show on your GitHub repo in the browser, it'll be a broken link. It's a fun thing to to see, but I'll just demonstrate here. You have to do other things, and my code actually does have sort of slightly more sophisticated functionality to shrink the animated GIF to be, of course, necessarily lower quality, but such that you're able to get around these, size limits. So I'm going to go here, movie GIF demos. Let me go through this here. And what was it? Blah, 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 blah. Create. Yep. This was the one. Okay. So I'm going to be a little bit honest here, and I'm just going to get rid of this. And what I'm going to do, you see, it just takes, give it the name of the movie, or use that movie flag, that argument for functionality, and give it the file name. And its vanilla functionality will be to create an animated GIF. And, for whatever reason, I don't know enough about FFmpeg to describe why, but it is a significantly slower process than, create an, standard MP4 or MKV movie from, a collection of images, frame by frame images. But it looks like it's done. And here's what I'm going to do. I thought we've got to open this up in a browser. So I'm going to do that, and I'm going to share the screen. Well, let's first go there. Actually, I'm going to go a little slower through it. What was it? Where did it go? Okay. I'm sorry, I'm going through this a bit slower, just so it looks a little more polished than it actually is. So okay, now I'm going to I guess let me just now share. What is it? Let me go back to sharing. Yeah, let me do a new share, which would be this thing here. So what you guys are seeing is my browser right now. Let me see if I can open it up again. Is what you're seeing is that animated 31.1 megabyte size GIF. So I just started it over again. I guess there's a hard way to restart the process, is to just reload the image. But as you can see here, here's the animated GIF that I'm showing you right now. And as you can see, I don't know how good your screens are at this, but even with this sort of high quality GIF that I have, there are still some artifacts you might be able to see. Like, by artifacts, I mean, graininess in terms of these images, or some sort of non-uniform colors, non-uniform coloration. But here's what it is right now. And I'm going to end at least this part with sort of a real, so to speak, world application, where I'm going to go to, I think the repo, the GitHub repo to which Woody alluded, and I'm going to go there, and is this repository, which is the thing called COVID-19 stats, the thing that created all those movie files, and show you what I mean by these animated images. So, for instance, animated GIFs of 6 of the metro areas that I'm interested in. I included Richmond, Virginia, because, I went to high school there. But like New York City, the worst one, the Bay Area, I've got to probably update it a bit, because I think in the past 2 months, the LA Metro has overtaken New York City as sort of ground zero, at least case-wise, in the US. There's the continental United States, which, you know, this is the GitHub only says 5 megabytes is the size of an external Git that I have. So it looks necessarily smaller. And 4 states, California, Texas, Florida, and Virginia. Virginia because, well, I grew up there from, you know, elementary school through starting college. And yeah, I know I went through quite a bit there. Um, what do you guys think? I could end with one last example. It's not so much something I use all the time. It's more something I like to do because is the noise coming from my end or from somebody else's microphone? I can't tell.
Someone appears to be eating their microphone, or rather, sounds
Okay,
like they
I'm always now kind of paranoid about is it myself that's causing problems or
Your new mic setup is great. The helicopter is no longer in the background or the
that's
foreground, is it?
right, exactly. I could end with one last thing. It's not so much something I use in my day-to-day work. It's more like, you know, I listen to this song on the, you know, outdoors back in the day in the store. I still kind of listen to it like over the PAs. So I Shazam it or I find it some other way. Basically, it's the tune I hear somewhere and figure out its artist name and song name. And I want to, you know, put this into my media server so that I could stream it to my heart's content. And that's something I do really just for myself. And let me go to that one. Let's go through here. I call it making music, but it's very simple. Little command line tool. You give it the artist name. You give it the name of the song. And what it does at a low functional level is it takes this metadata from what's called music brains. It's basically a giant server containing an index of, I think, every song that was recorded or a big chunk of it. And it provides, you know, a public-facing API to which you can query, and which I do query. It takes the audio from YouTube DL and actually uses also YouTube to basically figure out which of the clips, you know, match the song and artist name, combines them together, you know, YouTube DL to download, just the audio part, the metadata from Music Brains, and combines it into an M4A file, you know, an AAC file basically, that sits on your disk that has the proper artist and song name, and it has the, you know, all the metadata properly filled out. I guess I have an animation. Oop, what just happened here? Okay. Yep, an animation that demonstrates what I mean by that. But I figure it's easier to show rather than tell. You know, links, of course, exactly there. And I'm going to go back to demo mode. Let's make it a little more honest. In fact, this is something I probably won't have to go to the readmes to because I do it way too often. And I don't know, have you ever heard of a French electronic band called Air? I'm a big fan of theirs. And I really like all their old stuff, much more than their new stuff, which they don't seem to have a lot of. But I'm just going to demonstrate it here. So as you can see, you actually have the choice of choosing which, you know, music metadata server to use. I like Music Brains because it has sort of the best, most complete, comprehensive data, and it allows you to, as a user, to, you know, update, you know, put in new song information as it comes up. So see the way it works? It found it, lo and behold, Air. It's from the album Moon Safari. It's track number 3 of 10 that it found. And this is the important part. This is the sort of crucial feature that I stumbled upon a few months after I first wrote this. It also tells you the actual length of the song. So then you go to the YouTube clip that sort of matches best the song length. So I guess choice number 5. And there it is. I guess I thought I'd have some executable functionality to demonstrate, okay, yes, the metadata is actually correct, but I guess I could say you could take my word for it, or just try it out yourself and see what happens. Maybe play it on your computer, like get a song, an artist you like, and see if you can find it on YouTube. And with that, yep, I guess at that point, I think that's pretty much everything. Sort of a quick, relatively run through of stuff I do that are sort of self-contained, just one input to one straightforward output, that are yet, even with Python, fairly useful. And if you look through the code base, especially for the image auto-cropping, fairly easy to describe the separate elements of the functionality, like something that is only 50 or 60 lines long in Python, which try to do that in C or C++. And with that, all this stuff, lives on GitHub in public repos. So I guess Woody, I could put in the links to all of these, as well as the link to maybe the repo in which this presentation with demonstration stuff lives, in both the Slack channel and Discord.
That would be great. We'd love that.
And with that, you guys have anything else you want to talk about here? I know it's getting late.
So, I'm sorry, is my mic working?
Yeah.
I don't know why I have to keep asking that. It's my first time using Zoom, actually. I was wondering if you were familiar with a Python library called Click, because it seems to me that you really like doing the kind of like the command line interface tools.
I've heard of Click and similar things. I'm sort of an old hat. Back in the Unix days, I started off with optparse, and then I went to argparse, and sort of construction is pretty verbose, and it is a bit limited in terms of you can't do general branching of command line functionalities as you could, I guess, in Click and other tools, or it doesn't have the sort of conciseness of the more modern ones. But I guess I don't do too many complicated things, but I've heard of tooling like that. I guess if you're a young person, I would say go with Click and things like that to get something up and running. I guess that's what Click is, right?
So it's like an alternative to argparse, essentially. I think that the real killer feature of it is that it utilizes function decorators in Python primarily to kind of denote, certain functions as something that deserves its own command line argument.
Gotcha.
Which I'm not sure if
it's
you're
sort of an object oriented.
What's that?
I'm passingly familiar with decorators. The most usage I have of decorators are basically Flask endpoints. Like, okay, this is a post or a get verb that I'm implementing, or it's both. Or it's basically Flask stuff, but I haven't used, and class method and Flask stuff are the only decorators that I've been using. I'm not a big expert on that. This is true.
Yeah, they're a really powerful construct, but they're a little difficult to wrap your head around. I guess at first it took me, I knew probably like a week just reading over and over and over again, what exactly was going on with function decorators, because I'd kind of learned about them before you always hear people say like, oh, everything's an object in Python or everything's an object, but that wasn't really like solidified for me yet when I was learning about function decorators. But I would say if like you're pretty comfortable with like the fundamental concepts of object-oriented programming, that function decorators make a lot of sense.
I want to start getting into that, but I'm very lazy and very impatient, so that's not a good combo. So I'm like, it's got to be a killer feature for which decorators are a new programming concept are like, oh yeah, it either illuminates things, opens up a whole new area, or suddenly boilerplate code, and I do still write a lot of Python boilerplate, suddenly goes away in an
Yeah,
obvious fashion.
that's really the killer feature of Click is it gets rid of almost all the argparse boilerplate. And you know, frankly, you don't even really need to understand what's going on with function decorators that much to use Click. They're just so
Okay.
cool that I recommend checking them out anyway because it's not entirely unique to Python, but Python I think really takes advantage of functions being first-class objects a lot better
Yeah.
than say like JavaScript does.
I should like point out, let me see if I can open up sort of one of the biggest command line blobs of code that I have, and it's actually the part of the COVID-19 database stuff. Let me see if I can get that. Let's see, where did I put out? I think this is I have about 90 separate Emacs, windows open, and I can never remember where create movie or summary.py. Okay, so what I'm going to do is I'm going to share that thing for which I think something like click would be really useful. And I'm going to just close that. And let's see if yeah, here it is. So there's the stuff in the main block, which is basically, here's my command line front end. And yeah, it's just a bunch of code.
Yeah, I was kind of looking through the GitHub repo towards the end of the talk there.
Yeah, it makes sense to me, but it's very verbose. And if there's a way to compactify it in a logical, illuminating fashion, yeah, I'm all for it, especially for stuff that's like, this
I
is
probably wouldn't
200.
migrate an existing code base over to Click. I would just try to. Yeah, that'd be more work than Click would save you. It's not that magical. it's
Well,
it's
it
a
would
great
be
library.
sort of, in my case, I would have a new functionality, right? I would probably just duplicate the functionality with a different different name, but say instead of using argparse, use click, and see if it behaves very similarly to what I want it to. I mean, if it behaves if it does what I want to do, but better, then yeah, okay, that's even better than what I have right now. But yes, I guess my thing is, click or other better things I try to use, uh, you know, with something whose functionality I know very well and I know it works. And so then I would take it as an opportunity to make the code base cleaner. Start out with accurate and then move to lower footprint. And maybe if I'm lucky, get faster. Alf. But yeah, good ideas. There's actually other functionality that I haven't even gone into, like this updating, basically updating the COVID-19 data, summary data that I have. It's now up to like 45 separate regions, including the CONUS. So it's, however many MSAs, I think about 20 right now, and about, I guess, 17 states and the continental US. And so, to create each frame, it's not so bad. So multiply that by, 300 plus frames per region times 4 separate movies. It sort of adds up. Luckily, it's a parallelizable, embarrassingly parallel process. And you can say you're trying to learn how to do all this stuff for your work. It's sometimes beneficial to have a supercomputer to like farm out the work for you. So
I didn't look too far into it, but I know Python will typically it doesn't do multi-threading like as seamlessly as something like Haskell or Golang will do. It's kind of a struggle to get Python to run multi-threading. I'm not even sure if you. I believe you can only just spawn sub processes on another thread in order to get any
No,
multi-threading.
you can actually do multi-processing. A big problem with multi-processing, basically, you share the memory. The big practical issue I have it with is serialization. In that, if you use the vanilla multi-processing module, that's part of the Python standard library, you can only basically pass around some data structures. There's something called Pathos that uses a serializer called DIL, which extends beyond, Python's pickle to allow you to do, basically, at least in my use case, arbitrary levels of Python multiprocessing. That is, you can now pass around data structures that you couldn't before. You could actually do with, Pathos multiprocessing, you can actually give it, anonymous functions, lambdas and things like that, and it will just work, which is something that's not at all guaranteed. I'm actually not completely sure you can even do that with standard vanilla Python multiprocessing. And there are all, memory issues as well. If you use your threads, if you use a thread pool instead of a multiprocessing pool, you can quickly starve your virtual machine, or if you're unlucky, the login node of your supercomputing cluster of memory. And you get sometimes angry phone calls from basically IT on steroids saying, "What the fuck are you doing? Please kill your processes."
Yeah, these are all the terms and things that I use Python to stay away from for the most part.
The idea behind Python is, or any kind of programming, at least the way I see it, is to get to where you need to go in as logically and clearly and concisely a way as possible. Don't make more work for yourself than you need to, and do fun things that you like to do that you find useful. For me, that's the quickest way to learn. I I'm a combination of impatient and lazy. So at this point, if it's something isn't completely interesting and compelling and obvious to me, or maybe even not so obvious, I tend to just ignore it. And with Python, you can do a lot of the interesting stuff like that.
Very cool. Thanks so much, Tanim. This is a really cool set of utilities you got here. I think I might be borrowing your
Autocrop
creator.
Yeah, you could do the GIF
Autocrop.
creator. It's all
the
BSD2
GIF creator I wanted.
It's all BSD2 licensed, so go nuts with it. If you want to be sufficiently litigious, take that code and slap me with a lawsuit for infringing what you're doing.
No way. Attribution is the coolest. All right. Well, anyone else have any questions for Tanim about this, or we can start wrapping up for the night? It's getting to the end of our 2 hours here.
I was curious about the COVID data. Is that, it looked like that was coming in from the New York Times. Is that all like CSV data that you're using?
Yes, it is. Yes, it is. And let me show you exactly what I mean by that. Let's see. Oh, gosh, this is getting way too big. Okay, so if you see this here, you see a directory called COVID-19 stats. That's the name of the repo. And there's a thing called COVID-19 data. I knew something like this would happen. So let me go to someplace. Actually, I'm afraid of going to someplace else. But the idea is, let me actually go to my repo to tell me exactly what I need to do to repopulate it. COVID-19 stats GitHub page. So this is Sphinx, this thing that I like to use a lot. Okay, git clone. Okay, I did that. Git submodule. Let's see if I can get this to work. It's one of those things, I've got to be honest, that I do only once when I populate a repo from the beginning and then completely forget about it. It's now, about 350 megabytes in size. But, we've got fast internet. So, but yes, yeah, it's the New York Times COVID database. And that's a bunch of CSVs, which is, if you look through it, I don't know if you have, but yeah, it gives the county name, the date. It's basically a bunch of rows. The rows are the county name, or no, the county identifier. It's called a FIPS code. I'm not a GIS guy. The date and the recorded cumulative number of deaths and cases. And just millions and millions of rows. That's what it is. Let's see if I have this stuff. COVID-19 data. Yep, or maybe not that big, sorry. only 39 megabytes in size. That's how big the CSV is. So as you can see it here, if you can see on the screen, it's a data structure, a data file that's easy to consume. This was one of the things that I puttered around with, I think, in my first month. That's when I went up to the 50% functionality in the COVID-19 stats, that tracker repo that I made. Within the first month, I had a lot of, I had basically the consuming the data, getting the GIS, consuming the COVID, data, getting the GIS data structures. By GIS, I mean geographical and informational system. It's not too complicated, at least to me. It's just census data. This is a county with these many people in it. This is a county with, this lat long describing its borders. It might be contiguous, it might not be, but, it's a straightforward data structure. And then, started to create stuff like, okay, let me create a plot, coloring the number of COVID, cases and deaths in, say, the New York metro area. And then, building it off from there. First, I'm trying to do something that's accurate or correct, and then, try to optimize or make its functionality, both the implementation as well as the hooks to it, more and more logical. And then, building it up bit by bit by bit. And at a certain point, in the past, I guess, month and a half, I've created other automated tooling to collect, synthesize, or summarize, and then push out the data at a regular frequency. And so there's a GitHub repo a private GitHub repo that contains the sort of latest bit of COVID-19 data, like summarized data, those 40 separate regions. And it's private, but if you give GitHub money, it can put in a public GitHub page for that. So that stuff, I just push it up, all that data up, and so now it's hosted by GitHub. So presumably, I don't have to worry about, bandwidth limits and, availability. Yeah, I do try to leverage other people's resources as much as possible. But
Cool.
yeah,
No, that's super helpful. I'm trying to work on a React project in JavaScript and just kind of exploring local numbers related to COVID, like
right,
trying to
like
answer
the
the question
Sacramento
of,
area, right? The Sacramento Metro.
yeah, trying to, like, I live in Vacaville, so trying to say how, all the numbers are small when you look at Solano County, and so how do I know if that's a good number or bad number related to per capita and versus someplace like New York versus, when I was playing around, it's we're doing 4.5 times better than, New York over the
capita.
entire since like mid-March. Yeah, per
Right.
capita. And it's like, okay, that's good. Like, but like actually, like it wouldn't take that much for, but and you think, oh, maybe because we're more rural. So I read about this like South Dakota town, and it was like this in South Dakota, there's a county that was like 15,000 people, and they were doing almost as bad as New York was. And so maybe like rural versus city doesn't matter as much. And so
It's fun.
just
It's
interesting
fun.
stuff like
Yeah.
that.
It's fun with data science. I mean, you can actually have those scatter plots that you can develop. I actually have, I guess, incident data. I have data structures that make it easy for me. At a low level, one of them are pandas data frames. You know, if you define a region like a state or an MSA, one is a pandas data frame where, you know, the columns are the county, but identified by like zip code or county number. I don't even know what a FIPS is. It's some kind of code to me. And then, you know, it's FIPS number case, FIPS number death. The rows, and, you know, another column would be the date, right? And goes from first to last record, and it'll give you, you know, those numbers for that date. So pandas, I can't recommend that enough for, you know, time sequential or just sequential data that's not multi-dimensional. Yeah, pandas is great for that sort of thing. And it's all sitting there, and I haven't gotten around to documenting the API like I have for, I think I gave a link to Howdy and NPR stuff, where even the API documentation, at least it's complete. And maybe the comments within the code base are more illuminating than confusing. But yeah, um, I guess in my voluminous amount of free time, I guess I'll flesh out the documentation there for the COVID-19 stats repo. I'm starting to fill out the command line interface documentation more and more, but you know, it does take time. And Sphinx is an interesting beast. There is a method behind its madness, and I've been able to get it to make nice enough, you know, documentation that I can use pretty easily, and it's been useful to me too.
Hey Tanim, what kind of data structure are you using for like this kind of data when you're actually coding? So I know you're using it from a CSV, but what are you actually using?
Let me see if I can open up a Jupyter notebook that will do it for me. Oops, let's see if...
I imagine at this point you might be running across some size issues.
There are size issues. There's actually two types of data structures. There's the geographic data, which is sort of adaptation fixed, basically a bunch of constants or configuration data. That I'm not doing something smart about this, and I know, Claire, we've had conversations about, you know, putting it into a database with you, but
mind me.
no, it's fine, it's fine. I'm just gonna. I don't need to put anybody on the spot, but as you can see, the underlying sort of data structure that exists, that's basically loaded immediately. If it doesn't exist, it creates this from, you know, the underlying SHP files or what have you, are things in these pickle.gzs. And I think like the collection of all the lat longs for the counties in the US is this FIPS 2018 underscore data.pickle.gz. And let me just humanize the LS. You know, it's about 11 megabytes in size. And you bring up a good point. In terms of initialization, can take as much as 30 seconds to basically load and properly organize all the data, even in these sort of pre-compiled data sets. Once it does that, it turns out that there's also a little bit of time to consume that CSV file to get a complete record of cases and deaths cumulatively for all counties in the US and its territories. But after that point, it's a pretty quick process. That is, if I want to get, basically, it's like a slice or selection operation. If I want to select this collection of regions of FIPS, codes, I have natural organizations into states and MSAs and the US as a whole. But technically speaking, I can just give it a set of FIPS codes. It'll just select them. It'll give me, I can also even select a beginning and end date. And at that point, uh, that selection and then wrapping up is very quick. It turns out what makes it slow, you know, in terms of the operations I do, is to create those movies. So creating a single PNG or PDF file, it might take, about 0.2, zero point 0.3 seconds, but then you have like 400 of them. And it can't do that. I did try this out, trying to do this in parallel. Um, there's actually an initialization cost to it. It's just the nature of how matplotlib works. Um, the fastest you can do is you have basically the initial data structure corresponding to here are the polygons, here are the lines, and here's the points and things like that, and here's the axis and the frame. That part can take as much as 10 seconds to do. But then what you do is you go frame by frame and you have those data structures, and what you do is you just change the color of those polygons because those correspond to, different numbers of cases and deaths. And that's a very fast process. And that's the, 0.2, 0.15 seconds at that point. And so I haven't done an expansive search, but it ends up being something like, it takes quite a bit of time in the end to create those movies. But long story short, there are lots of things. I've tried to optimize this as much as I can without killing myself in terms of looking for, further optimizations. But even with that, it's a pretty slow process. I think for creating a movie of the continental US, because, a lot of polygons, right? And a pretty big, canvas. I think it took 400 to 500 seconds to create an MP4 file of that from, beginning to end. So it helps to have multiple, nodes to do this computation. And even with 9 nodes, it takes, an hour to complete, a cycle of beginning to end, newest bit of data. And I guess with that, one final thing, I know, I just keep talking and talking, but there's a Google Colab repo that has, actually, I think there's now 3 of them. Sorry, Google Colab Jupyter notebooks that that are publicly shareable. That is, you can just get the link to them, and I guess I could put those links in there too if they're not in the meetup. And you can just nice thing about Jupyter notebooks, they can run MP4 files, so you can check back in a day or 2 or 3. And you'll see, lo and behold, now I have data for the continental US up to January 5th, from the beginning. And just start from the beginning to the end. And it does it for...
And there are Colab notebooks in there, or they're Jupyter notebooks?
Yeah, they're Jupyter notebooks hosted at Google Colab.
Cool. I'll post the links in the chat. They're on the meetup as well.
Right. And you can see the link there. Though that's the hosted by GitHub. This is our GitHub pages that host these MP4 files, which, I guess 300, 400 people can load them up. I think that's fine. I think Google can handle it. I think GitHub can handle it. I'm pretty sure my machine at home might not be able to, but I guess if GitHub or Google has a problem, they could probably just send me an email. It's now about a 400 megabyte upload, basically push to GitHub each cycle, each update cycle. But yeah, I guess that's the one functionality I want to put in there, and I keep talking and talking and talking, is the 7-day average rate of new cases and deaths. I conceptually have everything I need for that. I have the underlying data structure. It's just I haven't looked at it in about 5 months. So I've got to figure out exactly where everything goes and then create similar plots and movies using now slight modifications of that data structure to now visualize, the 7-day average. A nice thing about the 7-day average is you can see flare-ups and die-downs of, specific regions in the U.S. With the cumulative, it's going to go from good to really bad, right? But with the flare-ups and die-downs, you can see, okay, it looks like there's a hot spot that developed, in this part of the U.S., but it might have gone away, stuff like that. Or, for instance, New York City. Yeah, it was extremely bad until, the beginning of May. Then it got, it really, stopped almost until the summertime, the end of the summertime. And then, oh, lo and behold, look, everything's rising up again, around November, December. That's when, stuff went to hell, especially in California, that sort of thing. But, well, if people do want to hack at it, I'm not going to turn away people who want to take a look at it. I'm willing to, provide as much help as I have the free energy to do to do this sort of thing. And in fact, something I could even talk about in at least a little bit of detail next week, or Meetup, or the Meetup after. Or I could even talk about Sphinx, doing practical Sphinx documentation and the neat things you can do with Sphinx that you can't do elsewhere, or how it adds value to the documentation you choose to create.
Well, I look forward to the next one. This is an incredibly comprehensive demonstration of a lot of the power of Python. This is awesome.
Thank you.
All right. Well, we're past our 2 hours here. I think we'll start wrapping up. I'm gonna steal the sharing back from you real quick.
Sure. Yep.
And we'll just do some housekeeping to wrap up here. But basically, at this point, we like to open up a little bit the floor for questions, as well as we like to sort of solicit any future presentations. Like if anyone's got anything coming up. Oh, yeah, we're not starting soon. We're ending soon here. All right, I got to figure out how to jump straight to the end here. But basically, if you got anything you guys want to talk about, if you got anything you need to present at work and you want to practice, or something you want to just get out there and let people know is available, we'd love to be the platform for you to do that. If you've got a moment and you want to do something, that QR code will get you to a Google form. I'll also post to the link and the Slack and the Discord. Also, we're putting together a mailing list. At this point, we're hoping for that. If you build it, they will come, sort of thing. But basically, we'll just be inviting you to the next events. So if you want to do that one, I'd say take a screenshot real quick. But yeah, let's see. So announcements. I think until the vaccine is working, I think we're going to be sticking with Zoom for the foreseeable future. But is anybody here got anything they want to let the crowd know about before we wrap up for the evening? Cool. All right. Well, thanks everyone for coming. We'll see you again next month, first Thursday of the month, as always. Next week, in the SacTech world, there's an AWS group that meets up that is pretty nicely subscribed. All right, I'm sorry, I gotta call this one out. Robert, you awake? Nope. You're gonna fall asleep. Turn off your video. All right. Well, thanks everyone. We'll see you guys next month. I'll post links to all this stuff. This will be on YouTube as well. Bye,
Thanks.
everyone.
Bye.
Bye bye.
Good night. Thank you, everyone.